From the massive studios in Raleigh, North Carolina, this is the Cloudcast with Aaron Delp and Brian Gracely, presented by A Cloud Guru, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive studios here in Raleigh, North Carolina. A couple of quick housekeeping notes. Aaron is out today, and for anybody who may have been paying attention to him sort of social media-wise, Aaron took a new job. That doesn't have any effect on the Cloudcast, except that every time Aaron takes a new job, it usually means he kind of dives in head first and probably won't be on the show for a little while he kind of gets his feet wet with what he's got going on. And when it kind of gets public as to where he's going, and he tells me and others, we will let you guys know as well. But he's definitely staying in the tech world and definitely will be still connected to the podcast and everything. We just need to get him back on when schedules permit. So, with that, if you were listening last week, you heard myself and Amy Lewis talking about, kind of this transition that a lot of techies often make, kind of getting out of being pure tech into, more prominent roles on the business side of things as things become more digital. And if you've listened to this show very often, you know that I've got a couple of things in my past that I always love to dig into. One of them is the automotive industry, because of my mother's side family. I used to work in the auto plants. And my father's side, going back multiple generations, were farmers. They grew up in Ohio. They were bean farmers and all sorts of things in the Midwest. And so anytime there's a chance to see the intersection of tech and farming, or what they now call ag tech, I'm always interested to dive in. And this past week, I had sort of an interesting one of those coincidental occurrences. I was flipping through LinkedIn and saw an old friend from back in my days at Cisco had recently started an ag tech IoT company, and I thought I need to go talk to him. And so it's great to have both my old friend Steve Ritter as well as Dan Casson from a new startup that's out trying to reshape kind of how IoT interacts with farming and so forth. So both Steve and Dan, first off, welcome to the show, and why don't you guys introduce yourself?
Thanks, Brian. Yeah, so my name's Steve Ritter. I've spent probably 15 years at Cisco, as Brian mentioned, focused on everything from new product development and launching a few startups at Cisco. And then the past few years focused on IoT and really caught the ag tech bug when I started to see how technology could digitize farming. And that's when I left and decided to start our company, Teralytic.
Yeah, but you, Dan?
This is Dan Casson, VP Engineering for Teralytic. So I've worked in the fintech industry a lot, but I grew up on a farm in Iowa, kind of worked there all the way through college. So after, moving through the fintech industry, getting heavily into cloud computing, working in some startups in, Silicon Valley and such, I made my way working a lot with IoT and machine learning, and then when I connected with Steve and we were had a chance to move back into ag tech, this is right where my heart is. Excellent.
So I'm very curious, just kind of before we dive into Teralytic, kind of how did you guys meet, and how do you what's the how do sort of people from Silicon Valley and New York City, obviously Dan, you're from farming area, but how do you decide that you're gonna kind of marry technology and farming, right? How do you get your sort of boots dirty from a technology perspective? I'm curious the origin of all this.
So what I found talking to miners, talking to farmers, was that they were really the original innovators. They're the ones that took advantage of the wheel, took advantage of the plow, and so then any time a new technology came along, whether it was machines and actual, tractors, or whether it was next generation chemistry to, produce modern fertilizers or pesticides, they would adopt it. But that technology in the IoT space, in the drone space, a lot of farmers were complaining that they weren't getting the data they needed to make their jobs easier, to make them more profitable. And one of the biggest areas that they were complaining about when using next-gen technology was around soil science. And there just wasn't enough data, or there was too much data to be had that wouldn't allow them to make a decision. So when I started looking at IoT and marrying that with ag tech, that was the first place we looked to start, was how can we give farmers better insights into their soil to make better actionable decisions. Within New York City, there's a lot of indoor ag. There's actually probably the ag tech capital of the world when it comes to indoor agriculture. You have Elon Musk's brother rolling out warehouses upon warehouses of next-gen nurseries, growing local groceries for supplying local restaurants and Whole Foods type locations. But yet, so there's a lot of ag tech talent in New York City, but yet no one's really looking at it from the traditional Midwest, traditional California crop type. And so that's really how a guy from New York decided to go after that market.
Interesting. So, at a high level, and we'll dig into this. You guys provide, Teralytic provides both the sensors that are out in the field in the soil, as well as the technology up in the cloud that's going to help analyzing this. And the initial play is around what people will shorthand call NPK, or nitrogen, phosphorus, and potassium levels. Sort of what's the makeup of the soil, how it's changing. I'm curious, Steve, like what are the big challenges today for kind of understanding soil? Like how people tend to think about IoT being, constant monitoring and like, does soil change all that much? What are the big challenges for, what did you find was lacking in the sort of soil knowledge space that drew you to kind of go try and solve some problems for them?
Yeah, I think first off, soil is one of the most fascinating ecologies you can actually study in Earth. People know more about space than they do about soils. So there's just a real live, environment under our feet that nobody knows about from just a domain knowledge perspective. And then from a technology perspective, there just aren't a lot of tools that are affordable that give the right data to a grower in order to make decisions, both to understand what's happening as they apply fertilizers and amendments. How does that affect their soil health and soil composition, and how does that change over time as temperatures rise and fall throughout the seasons, as irrigation events happen. So really, just getting some eyes under the ground, in this case, sensors, to help farmers see what's going on down there before it manifests in the plant was a huge opportunity and a huge boon for farmers.
Okay,
that's right. I mean, and the current state of soil testing is, farmers will have core samples done at strategic areas around their farm, and maybe that happens once every 2 to 3 years, and then they from that point out they're kind of extrapolating and using maybe some models, but a lot of times guessing how the soil is reacting, as Steve alluded, with variations in temperatures, with weather events, as well as all the actions they take with fertilizing and irrigation and such.
Okay. So even, like I was looking into the product, even with it just providing updates every 15 minutes or so, and only, I was sort of surprised as I was looking at, there were some questions, how many sensors do I need? And you sort of laid out, well, it could be, one every 5 acres, it could be 2 to 10 acres. Like, it seemed like, okay, this isn't a lot of data, but you're sort of saying, look, even just on that, it is significantly more than they ever had before, because they were doing it, on the order of like a couple times a year, as opposed to, hundreds of times a day with, more active technology.
Exactly. Just they were getting snapshots before the plants went into the ground as seeds, or they would get a snapshot after everything was harvested right before the winter. And during the growing season, they had no data. They had no insights what's happening. And so, as Dan mentioned, they're almost flying blind, guessing at what's going on down there, using rules of thumbs that have worked in the past, or models that the local ag extension groups have been giving them to best figure out what to do without actually knowing if it's making a difference or not. Okay. And so that's led to a host of problems, whether that's wasting money on fertilizer that the plants don't need, that then just gets washed off as an environmental waste into the waterways, or burned off as a greenhouse gas, or it just became a profit train because they were spending more than they needed to on ag input costs, whether it was fertilizers or amendments.
Okay. So this is both looking at this from a profit perspective, as well as a kind of an environmental, good citizen perspective, which is excellent. So before we dive into some of the technology, which I know our listeners always want to kind of dive into the tech, I'm curious about kind of the business side of being in the IoT business, sort of the business side of IoT sensors, if you will. I know a lot of times people just think of them, they go, well, I've seen a Raspberry Pi, or I've seen, some prototype from an Intel device or something. And you guys are building these sensors, right? You've got some unique intellectual property around the sensors. Steve, as the CEO, as somebody with a deep business background, can you give us kind of some of the high level stuff around what the business looks like to be in sensors? I mean, just a little bit about, kind of mass production. Where does mass production make sense for you guys? How much do you have to think about just how simple the installation has to be? Because it's not like somebody's driving a telco's driving out with a truck and, wiring stuff up. And I mean, like, how do you have to think about, kind of the business side of being in the end device perspective for IoT?
Yeah, that's a great question. So I think the first thing you heard from the market was, farmers didn't want to be that integrator. They wanted an easy to use, easy to install, easy to understand solution. So we approached everything we did, from the hardware to the analytics to the networking to the installations, through that lens. So when I first started the company, I just assumed soil sensors were on the market. We could purchase them, add some sort of Wi-Fi technology to it, and focus on a cloud analytics platform to make it all usable and understandable. And quickly came to find out that, if there was a technology on the market, it was thousands of dollars per sensor to measure one data point, whether it was moisture or EC, and or it wasn't wireless. And so we had to start from scratch and work backwards to develop our entire owned and operated sensor that would measure everything from moisture to EC to NPK. And going through that process, we had to mainly focus on keeping the costs down, because we kind of subscribe to that Andreessen Horowitz model of hardware is going to be free. It's really the data exhaust that provides value to growers and to end users. And so we spent probably 18 months in stealth mode, developing our own hardware from scratch, building our own wireless technology, building our own back-end analytics platform, just so we could, keep the costs of our technology low cost, so that customers could afford and adopt this in any crop, whether it was broadacre crops that yielded, something in the canola space, or whether it was a high-end, strawberry grower or vineyard in California. We wanted to make sure all the different growers could afford it. So from that perspective, working on the hardware, we actually had to develop our own semiconductors. We had to actually work with fabrication houses to fab our wafers. We had to find our own manufacturing around the world, and we've had to manage and operate our own supply chain.
Yeah.
Right now, for us, it makes sense to manufacture in Asia, but with automation and with robotics, it may make sense to bring it back into the U.S. If we can get a high volume, high tier one provider with enough volume on our side, we may actually bring all manufacturing back to the U.S. Because it's cheaper with robotics to do it than it is to have it done in Asia and ship it over here and wait 5 weeks for the product to get back here.
Right. Interesting. And so, yeah, like you said, farmers don't have IT departments. So it literally, I assume, they want to just get it. It comes in a box and you just tell them where to stick it in the ground, I would assume.
That's exactly it. So we built our own online tool that helps the farmers load up the fields, understand the different soil types in that field, figure out using the tool where to place the sensors, so that when they order the sensor, it basically is plug and play. All they have to do is dig a 3-foot hole, turn on the power button, and everything happens in the background, just like you would see with a Nest or some other, modern IoT device. There's no configuration. There's no protocols to set up. There's no wireless network to set up. It's just literally plug and play, so that farmers can, easily get these out into the field. Because one thing we found was, farmers are not afraid of hard work, not afraid to get out there and install these, but they did not want to deal with the headaches and integration challenges and setup challenges that technology has imposed on them so far. So we actually hired our own UX team in-house just to work on those types of issues to make installation as seamless as turning on the button.
Nice. So, let's talk a little about the IoT sensors at the edge. Obviously, they have to be very precise. They have to be inexpensive. There's lots of environmental considerations to have. And to a certain extent, you've got to plan for the future because it's probably not a device that you're going to go out and do a truck roll on and, do an upgrade every couple of years like a consumer device. How do you, what's the mindset that you have to think about kind of all those variables? Like how much is industrial engineering, how much is computer science, and how much can you just get off the market today, or do you have to build yourself?
Yeah, it's a great question. I think from our perspective, growers expect, durable machines that run in all operating environments. So from our perspective, we spend a lot of time up front designing this to look and feel and act and be as durable as a machine on the one hand. And on the other hand, we had to still make it low cost enough so that it looked, felt, and acted like a low cost sensor. So before I moved into IoT, I would have never really paid attention to the term quality as number one. But really, that's 100% of what we focused on for the past 18 months was building in the durability, building in the weatherproofing, building in the quality so that as these sensors get out in the market, they don't fail. They don't have to be replaced every 6 to 9 to 12 months, and they can last as long as you would expect a John Deere tractor or a Jeep to last in the outdoors. So from that perspective, we spend a lot of time on the industrial design to make it last, to make it work in all environments, all temperatures, and just stay out there. Because as you said, these sensors could be going out to the middle of Indonesia. They could be going out to the most northern regions of Canada, into the rainforests of Brazil. And there aren't truck rolls. There aren't Mac or Apple stores where you can just bring it in and talk to a genius. So we had to really think through how to build in quality and durability and weatherproofing up front.
Right. Dan, I want to kind of bring you into this. Let's talk about the analytics cloud. That's from a technology side. That's your background. You've got these devices collecting information, sending up things up into the cloud. What does an IoT technology stack have to look like, both in terms of you being able to manage it and scale it, but also things like how long do farmers want to retain data? Because historically, you have the Farmer's Almanac, and you're going back, years and decades. Like, walk us through kind of the thinking of the analytics stack that helps power the cloud service that you provide.
Sure. Yeah. So it kind of starts with, it kind of starts with the edge. These are going to be positioned, as Steve mentioned, in, different places around the world. So, it starts with, design your cloud infrastructure to be able to support that, because, we don't want to, have sensors in, say Malaysia, having to, communicate back to our, cloud infrastructure in, North America. So we want to make use of, edge computing to, be our role of ingress, as well as being able to filter data back down to it. So, we're also what also goes into that is leveraging a serverless infrastructure over say staging VMs whenever possible. I mean, and that includes our our persistence layers as well. So we're making use of we utilize the AWS cloud. Okay. So we're utilizing their their edge locations and their global tables for Dynamo database and our Edge Lambda functions as well to filter data back, and then when it reaches our our IoT processing, I mean, we're using again kind of a serverless model to be able to scale up to as we add to our fleet of sensors that reaches tens of thousands, hundreds of thousands, millions. We're using that that cloud infrastructure that can scale to meet that need. With a rules engine, and then downstream processing, we're using we're processing our analytics and data in real time, versus doing batch processing. We're processing and doing our analytics, looking for things like anomalies in our sensor readings. So that speaks to things like the health of our fleet. If these sensors are in a harsh environment, right? I mean, and subject to but they're subject to weather and damage from animals or whatever,
Sure.
or collisions with vehicles or whatever. So being able to detect any outages or anomalies in readings, and so we can keep the data flowing in at a high quality and flowing in at a consistent rate to make sure it's serving the grower as best we can. So we're using those kinds of strategies to allow us to have a global reach, but still have a very powerful and scalable set of tools that we can harness to provide a rich set of analytics on, as I mentioned, things like hardware management, but also as they move up, being able to leverage the analytics side of things, for determining, maybe a situation where nitrogen has a danger of burning off or leaching into groundwater sources. So we have a lot of applications like that we utilize, across a lot of purposes. The hardware management and internal operations, as well as environmental needs and also plant health and soil health.
Gotcha. So you've got to just like on the sensor side, you've got to sort of be thinking multiple years down the road. You've got to be thinking about a lot of kind of difficult situations that could come up. On the cloud side, you're basically saying, I want to have unlimited scale, but I don't want to have to necessarily provision that ahead of time, because depending on how big the fleet is and at any given time, you may not need it. It sounds like there's an element of sort of real-time data where it makes sense, right? Cache where you can, close to the edge, collect things in real time when you can make actionable items, and you've got to be able to plan for anomalies where you don't want to tell a farmer that you've detected an anomaly that he could perceive as kind of catastrophic for a crop, when it could just be an infestation of gophers or something that started chewing on these things and throw things off for some section of the field.
That's exactly right. I mean, nothing worse than no data is bad data, and so being proactive and actively monitoring the health of our sensors, is key to building trust with our with our customers, but also maintaining a high quality infrastructure that we can take action when needed.
So I'm curious. There are obviously there's been some consolidation over the years around farming, and do you go directly to farmers? Is there a whole ecosystem of sort of systems integrators for farming, for ag tech? How does what does that part of the world look like for those of us that are used to selling computers and software and so forth?
I'd say it's exactly like we're used to in the computer and software world, where there are value-added resellers and distributors that own that end relationship with the grower, and they're either selling them machinery and equipment, they're selling them ag inputs, or they're selling them advice on how to best manage their yields and crops. So we see us selling through these types of distributors and trusted advisors, just as Cisco sold through resellers. But then we do get a lot of direct leads that come in through the online channel as well. So we want to be educational to the growers and help them understand the importance of soil health, as well as continuing to educate the reseller channel on how to actually use this technology to improve their own business.
Yeah. Yeah. So I'm going to kind of wrap it up. I'd love to get one last kind of piece of input from you guys. Obviously you guys found each other. Steve, like you said, you were interested in, mining and ag tech. Dan, you've got a background, both in tech, but also having grown up on a farm. Like somehow you guys found each other. Any advice for other people out there who, maybe are techies, but have an interest in a vertical industry or, people in some other vertical industry that are, have an idea for tech? Like any suggestions for people kind of finding a counterpart in starting a business? You know tech and they know the vertical. Any suggestions or things that you've seen just over the last couple of years as you're building this out?
I'd say you need both domain expertise plus deep technology expertise in order to build a well-qualified team. And so I had a lot of IoT and raw technical expertise, but working with Dan, who grew up on a farm, I think that's key because you can build all the wonderful technology you want, but at the end of the day, the values it gives back to you, the data it gives back to you, you'll have no idea what it means, if it's good or bad data, if it's helpful or useful, unless you can combine that with domain expertise. So from my perspective, we only hire people that have both either an ag or a bio background and deep domain expertise. We have 8 PhDs working across the company, full or part-time, who not only know something about soil science or chemistry or material science, but can also code and develop technology. And that's, I think, key to building a credible product in your vertical domain.
Right.
I think what you brought up was important about having a profound interest in a domain coupled with, a discipline that you build expertise in. The two reinforce each other, and it's kind of a force multiplier for you to be effective in your industry is my experience. And it gives you that interest that drives, kind of really engages, people you're talking to with the questions, the back and forth. So yeah, I think that's a very important point of having the two spheres overlapping here, and just really strengthens it's really a synergy. Yeah.
Yeah. No, and I think I think with the world changing, we're seeing the dynamics of kind of urban life. Like Steve mentioned, you've got people that got warehouses full of indoor produce. You're going to have transportation's going to change both inside of cities and outside of cities, and there's just a ton of different opportunities for people that are interested in verticals. If you have a deep passion around something, there's definitely opportunities to marry that passion of a specific vertical or a specific science or whatever it is with technologists that they might be able to help you, whether it's on the data side or building out hardware or whatever that might be. So very, very cool what you guys are doing. Real quick, before we wrap it up, what's the best place if people are interested in getting engaged with what you're doing, trying out the technology, any of those what's the best way to reach out to Teralytics or either one of you?
I think the best thing to do is start at our site. We'll be adding more and more info to it over the next few months. That's Teralytic.com. Otherwise, if they just want to reach out to me, they can email me at steve@Teralytic.com.
Okay, cool. And we'll get all
and
that.
I can be reached at Dan@Teralytic.com if anybody wants to talk tech and ag tech.
Very cool. Very cool. We'll get all that in the show notes. And I signed up for an account the other day just to sort of see what was going on. It's very, very simple to get signed up and all. So, definitely very cool, the stuff you guys are building. Well, guys, listen, thank you so much for being on. It was, Steve, it was great to reconnect, and it's very cool to see, basically almost the world's oldest, sort of technology problem, like you mentioned, essentially eating. It's the core of life is being transformed. So it's very, very cool to see what you're doing, and would love to catch up at some point 6 months, a year from now on the other end of a crop season and see the success that you guys have out there. Well, folks, with that, we're going to wrap it up for both Steve and Dan, and for myself and for Aaron. We're going to thank you for listening this week, and we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more podcasts, show notes, and everything social media. And visit acloud.guru for all your cloud training needs.